Hello, everybody, and welcome to this and welcome back to this episode of Dev Show. We have had Build last week and another break from Dev Shows, but now we're back and as you can see, it's myself, Rasmus, and then we have Göran, well-known face. Welcome to Dev Show as well to you. Welcome back, Göran. Good to have you here as well. How are you?
Hi Rasmus, I'm great. It's nice to be back here, and honored to co-host this again. Yeah.
Thanks for stepping in, and just the service information that I'm here with Göran in the beginning, and Sherry is gonna end the show together with Göran. So it's gonna be a mix and match, but it's you get a little bit of everybody. So that's amazing. And just before we start out, as always, we have the chat, and please interact with each other. And we have our code of conduct on the meetup page. It's right there. And basically, it just says be nice to each other and kind of mindful of what each other says. So use the chat, and also for questions. At the end of the session, we will have the speaker answer all the questions that you might have related to this topic. So put those into the chat along the way as well. And so Göran.
Yes.
We have an interesting topic as always on the agenda today.
Yeah, definitely.
So we're gonna talk about AI, and you also know a lot about AI, right?
Yeah, I'm kind of in that field, interested in that.
Exactly. So right now today we're actually gonna learn about how you can predict earthquake damages with Azure ML Workspaces. So that's gonna be interesting. Have you also tried to do that?
No, I haven't, but I look forward to hear about it and to learn more.
Then we can learn a lot, both of us today as well. So in this, we have Eva says the speaker today have said we're gonna get an introduction to data science and machine learning, understand how the importance of AI, and also what Azure Machine Learning Workspaces is, and also how you can use the workspaces and how you can go even deeper into the field. So I don't want to talk anymore, but now I just want to say welcome to you, Eva. Welcome to Dev Show.
Hi, thank you for having me today. It's really nice to see you guys. How are you?
And likewise.
Good.
We're good. How are you?
I'm feeling amazing. I'm really excited about today, and it's really cool to be here in Dev Show for the first time, actually. It's really cool.
Amazing. So I said in the beginning that we're gonna learn a bit about the AI today, and you are very active in the AI community. Can you talk a bit about what you do there? So in the community.
Yes, thank you for asking. I am one of the board members, for example, of a global AI community, which is organizing the global AI on virtual tour for this month. So you might want to look it up because we come again back with awesome sessions with awesome speakers. So it might be interesting for you. And next to that, we started together with another AI MVP, Håkan. We started this AI 42, which is aiming to bring in more people into the field of AI. I'm going to talk about these a bit in details later.
Amazing.
That sounds great. Yeah. So what do you do in your professional life? Besides all these activities, there's a full-time job also, I assume.
Yes, I do have a full-time job as well. I am working as consultant at Avonad. Right now, I'm working on a really interesting project as an AI engineer. I am moving an existing machine learning solution into the cloud to Microsoft Azure. So it's pretty exciting.
Nice.
Amazing. So we just before we started the show, we talked backstage about something you also do outside of IT. So can you just share a bit about that?
Yes, I think I know what you mean. I think you're talking about that I am a big fan of singing. That's my biggest hobby that I'm doing. Honestly, sometimes even after work, I stand up from the laptop and I walk around in the flat and start singing. Back in time, before I was very much into tech life, I was going to competitions as well, where I had to sing a lot, and many time I won those competitions as well. So that's
Amazing.
I think that was
That was
Nowadays,
exactly what I meant. So thanks for sharing that.
yeah, nowadays, if you're lucky, you can find me in some karaoke bars in Denmark. So I hope to see you there sometimes.
Nice.
Nice.
Great. And you're AI MVP. So could you share some info about that?
You mean how can someone be an AI MVP, or what am I doing as an MVP?
Yeah, maybe even what it is for people watching, just to understand what
Sure.
MVP is, and yeah.
Yes, this is like a recognition given to people who are in the field of AI. There are different MVP recognitions in different fields, and it is Microsoft recognition. That is why it is called Microsoft MVP. In a longer form, Microsoft Most Valuable Professional. And it is given to those who are active in the community by sharing knowledge or mentoring others, and by be close to the fire. I guess that's the explanation, really. That, for example, I often have meetings with the Microsoft product groups to get an insight into how this and that works. When is it going to be released? I can be prepared before it gets in what is it called, globally available. Yes, and generally available. Sorry, yeah, the GA, and so before that, I have the chance to try it out, give feedbacks, maybe help in improving it sometimes. So MVP is a really, really amazing stuff. I think it gets you a really good opportunity to get to know more, and I think it helps a lot for consultants too.
Great, awesome. So should we start?
Yes,
or
sure.
Or you have some other question, Rasmus?
Definitely. Let's hand over the stage to you, Eve, and then I'm just going to put your screen on the broadcast and jump in the background. Take it away.
Thank you a lot. So welcome, everyone. I'm very happy that I can be here and talk a bit about how to save more lives with Azure Machine Learning Workspace. Because in the last few years, artificial intelligence has become more and more prevalent and powerful. And many speeches around AI nowadays explain how these technologies can be benefited to predict stock prices or create value for an organizations. And in fact, even the online courses that are meant to educate newcomers in the field, those are also focusing on the financial benefits of AI. So in today's materialistic world, I'd like to focus on how the very same technologies can be benefited to predict natural disasters and eventually increase survival rates and improve quality of life. We have been talking a bit about me already, but let me give you a bit deeper introduction to myself. So I am Eve Pardy, or Eva Pardy. I'm a senior analyst consultant at Avanade. Avanade, it's like in Avanade, we tailor the right mix of expertise, knowledge, and agile delivery to support the client's individual digital transformation journey to ensure successful outcomes. So our vision is to be the leading digital innovator, creating great experiences as we realize results for our clients and their customers through the power of people and the Microsoft ecosystem. So our purpose is to make a genuine human impact. We want to bring people together to create an actionable and ambitious vision for mutual success. So we always deliver engaging and easy to use solutions fast. We think agile and use scalable technologies. And if you would like to join this family, please don't hesitate to contact me. So as we have talked about it, I have been an AI MVP for more than a year now. And since that, I am involved in different community activities. For example, I am a board member of the Global AI community and co-owner of AI42. Both are aiming to share knowledge in the field of AI with the community. And AI42 aims to provide valuable series of lectures that will help people to jumpstart their career in the fields of data science and AI. And in the following weeks, we're going to have great speakers, also from Microsoft, who brings you rich content about data science, machine learning, deep learning. They will also talk about tools like Excel, Power BI, Databricks, and a lot more. So if you want to be updated about the upcoming sessions and news, you can follow us on Instagram, Facebook, and Twitter. And you can also scan our QR code to get to our YouTube page, where you can watch our previous lectures. And at our meetup page, you can find information about our upcoming sessions. I can share these links with you at the end of the session. I additionally write articles and speak about my investigations and projects at conferences or other community events too. My aim is to save lives and support humanity with AI and data. It is also important to make people feel safe while using intelligent applications and make developers understand how they should control their solutions and hence gain their clients' trust. So I would be very happy to answer all your questions after the session. And if you're stuck somewhere while you're trying out the tools I show you today, feel free to reach out to me. You can find me on LinkedIn, Twitter, and Facebook too, but you might as well write me an email. So the disasters caused by natural phenomena have been present all along human history. Nevertheless, their consequences are greater each time. And this tendency will not be reverted in the coming years. And on the contrary, it is expected that the natural disasters will increase in number and intensity due to the global warming. According to world statistics, the increase in number of world disasters between the decades of 1987 to 1996 and 1997 to 2006 was 60%, going from 4,200 something to 6,800 or so, whereas the number of dead people during these periods increased 100%. It went from more than 600,000 to more than 1.2 million. And in the coming years, this tendency will not be reverted. It is foreseen that natural phenomena will increase in the number and intensity due to the global warming. And you might have heard about this, but more than 9 million Australians have been impacted by a natural disaster or extreme weather event in the past 30 years. And the number of people affected annually is expected to grow as the intensity and in some areas, the frequency of these events continues to grow. And these costs include significant and often long-term social impacts, including death and injury, as well as impacts on employment, education, community networks, health, well-being, and I could go on. Humans have been trying to predict earthquakes at least since the 1st century China, when they used this device like a jar with the metal dragons facing each compass direction and surrounded by frogs with their mouths open. And if the ground shook somewhere in the region, the metal ball in the dragon's mouth would drop out into the frog's mouth. So it draws roughly indicating the direction of the earthquake. And many similar predictions actually sounded reasonable. But after some research, those things were concluded to be natural phenomena with little to no correlation to earthquakes. AI, however, relies solely on data. Multiple researchers are creating their own applications to predict earthquakes and aftershocks. Moreover, these systems also monitor aging infrastructure. AI can detect deformations in structures, which can be used to reduce the damage caused by collapsing buildings and bridges or subsiding roads. So, during this talk, you will see a real-life example of saving more lives with AI, how to examine a natural disaster, how to use that observation to save more lives. Now, let me show you a story that motivated me to use AI to save more lives. I'm going to go a bit deeper into this video so you see the damage that it occurred. So in April 2015, there was an earthquake with 7.8 magnitude and an epicenter in the Ghorka District of Nepal. And this disaster killed almost 9,000 people and injured 22,000. This horror was, in most cases, caused by the collapsed buildings in the earthquake. Many data scientists have been working hard to improve the survival rate of the next earthquake. Our mission is to build a predictive machine learning model to investigate and understand the risks of damage in case of another natural disaster. The result of our findings is available for mitigation of which buildings might need strengthening before the next earthquake. By this, not only the memory of buildings and homes could be saved, but also thousands of lives. So I have been talking about data science. But what is data science? So data science is really just an umbrella term. It refers to figuring out ways to study and solve problems with data. And to do that effectively, you need a range of skills like computer science, mathematics, statistics, and whatever domain you are in, you need expertise in that domain. For example, for this project, you might need to understand architecture and some kind of forecasting of natural disasters. Data scientists are absolutely obsessed with data. The first thing we always do if we have a problem to solve that, we are looking around for all the possible data sources which we can bring to bear on this problem. And then we have to figure out how do we acquire the data? How do we get into some systems such as a data warehouse, Databricks, or Azure Machine Learning Workspace? But of course, the data is not always arriving in the shape we hoped for, so we might have to spend a lot of time on transformation, cleaning, reshaping, and so on. Then we need to understand the relationships in the dataset. Like, what is the data trying to tell us about a problem we are trying to solve? Which of the features or variables actually seem to be useful and which may just add noise to the situation? And finally, we are going to do some predictive analytics or machine learning modeling. And through that, we hope to deliver value back to our customers or end users, which helps them drive decisions and make them even better also. So I often see some confusion around the term machine learning and AI. So let me try and clarify how these are connected to each other. So artificial intelligence is a technique that enables computers to mimic human intelligence. It includes machine learning, which is a subset of artificial intelligence. So machine learning includes techniques such as deep learning, which are neural networks that permit a machine to train itself. And with machine learning techniques, we can enable machines to improve at tasks with experience. But how a machine could be trained? Now, let's see some machine learning techniques, the supervised and unsupervised learning. I often explain this with some very simple ideas. So imagine supervised learning as I'm giving you like the machine some pictures of apples, and these are going to be called like my features. And I'm also giving a label for these images saying that these are apples. And the machine is learning this. If it sees a picture of an apple, it is going to be an apple, right? Similarly, I give some images about bananas. Then I give it a label, bananas. And then the machine will be able to learn based on these images and the label what is an apple and what is a banana. So next time, if I give it an image of a banana, for example, without a label, it should be able to make a decision whether it is an apple or a banana. So this is the supervised learning. What is unsupervised learning? It's like, imagine I'm giving the machine a bunch of data, like some words saying apple 2 blue, banana 3 yellow. And then it's like and a lot of data. And from this data, it tries to make assumptions that, okay, this is connected to this, that is connected to that. So, okay, I got some fruit, I got some colors, and I got some numbers. And it tries to categorize these basically. And then based on this learning, it will be able to learn and make decisions when it gets a task to do so. In this task, session, we are going to focus on supervised learning. And there are several types of supervised learning. When, for example, the data are being used to predict a category, supervised learning is also called classification. And when a value is being predicted, for example, car prices next year, the supervised learning is called regression. And the approach that anomaly detection takes is to simply learn what normal activity looks like and identify anything that is significantly different. As a next step, let me sketch you up the main steps you need to take while working with machine learning model. First of all, we have to prepare the data. So we pull in the data into some system, in our case to Azure Machine Learning Workspace, and prepare it for training. This involves data cleaning, like excluding data that gives noise, some transformation, featureization, like splitting to train and test data, because we will use some data for training and some data for validation. And then the next step, we need to train the model. And training a machine learning model starts with choosing which specific algorithm we want to configure our model with. And you maybe choose a not perfectly fitting model first, but the next steps that are coming after training support you to improve your models. And it is maybe necessary to retrain a well-fitted model if there is like a change, for example, in the data. So what are these next steps that are supporting you is like, for example, scoring the model. And this is the process of generating values based on a trained machine learning model. The generic term scoring is used rather than prediction because the scoring process can generate so many different types of values. List of recommended items, numeric values, a predicted outcome, and so on, depending on what data you provide and how you train the model. And then finally, evaluation, which basically are metrics that tell you how good your model works. For example, the accuracy of a predictive model means that how well does it predict the future. So what we want to do is to build a predictive model which is able to answer our question by learning from the data we provide, which buildings are in danger when another earthquake comes. Predictive analytics deal with designing statistical models or machine learning models that predict. They are calibrated on past data, like the features, and then they learn from it to predict the future, so the labels. And while working with a predictive model, keep in mind that it's not always working perfectly for the first try, and that you might have to apply some improvements on your data set, your algorithms, and so on. But the best result is the aim always, which is why I think machine learning itself is also an always improving field. So this might sound like some kind of black magic, but thanks to the tools provided by Azure, you have the chance to easily get started with machine learning and learn about the different training algorithms and then understand what the result tells us with the use of Azure Machine Learning Workspace. So, but what is Azure Machine Learning? First of all, you can access machine learning for all skills and by that boost your productivity. You can build and deploy machine learning models quickly using tools that meet your needs regardless of the skill level. You can use the no-code designer to get started with machine learning, or you can use the built-in Jupyter notebooks for a code-first experience. You can also accelerate model creation with the automated machine learning UI and access built-in feature engineering, algorithm selection, and a lot more features to develop high-accuracy models. You can also set up operations with MLOps, which is basically DevOps for machine learning. It streamlines the machine learning lifecycle from building models to deployment and management. You can use machine learning pipelines to build repeatable workflows and use a rich model registry to track your assets. You can also manage production workflows at scale using advanced alerts and automation capabilities. You can also take advantage of built-in support for popular open source tools and frameworks for model training and inferencing. Like you can use familiar frameworks like PyTorch, TensorFlow, Scikit, and a lot more. You can also choose the development tools that best meets your needs, like including popular IDEs, Jupyter notebooks, and CLIs, or languages like Python or R. You can also build responsible solutions on a secure, trusted platform. You can access state-of-the-art technology for fairness and model transparency. You can use model interpretability for explanations about your predictions and to better understand the model behavior. With all this, you can reduce model bias by applying common fairness metrics that is automatically making comparisons and using recommended mitigations. You can additionally apply audit trail, quota, and cost management capabilities for better governance and control. Now, let me show you how the workspace looks like. So, excuse me. So this is the top-level resource for Azure Machine Learning, providing a centralized place to work with all the artifacts you create when you use Azure Machine Learning. The workspace keeps a history of all training runs, including logs, metrics, output, and a snapshot of your scripts as well. You can use this information to determine which training run produces the best model. You can deploy your models to Azure Container Instances, Azure Kubernetes Service, or to FPGA as well, and also to Azure IoT Edge as a module. On this diagram, you can see the different components of the workspace. The user roles enable you to share your workspace with other users, teams, or projects. The compute targets are used to run your experiments. And when you create the workspace, associated resources are also created for you, like the storage account, app insights, and so on. The experiments are training runs that you use to build your models. And then pipelines are reusable workflows for training and retraining your model. And you can also upload your own data sets that you use for experimenting. You can also deploy your models from here. And then you first would register them, and then they can be reached via the deployment endpoints. Azure Machine Learning Notebooks, which is one of the components of Machine Learning Workspace, this is a fully managed cloud-based solution for data scientists to get started with machine learning. Notebooks are deeply integrated with Azure Machine Learning Workspaces and data stores. It provides first-class experience for model authoring through integrated notebooks using Azure Machine Learning Python and R SDK. And with notebooks, we can leverage management and enterprise readiness capabilities for IT administrators as well. So it makes your work more productive. You can build and deploy models easily using integrated notebooks and popular tools. It enables you to collaboratively debug models and share notebooks within the boundaries of the workspace. Notebooks are managed and secure. They are pre-configured with up-to-date ML packages, GPU drivers, and everything data scientists would need to save time on setup tasks. And notebooks are also fully customizable. It provides broad support for Azure virtual machine types and persistent low-level customization. Now, I would like to demonstrate how to use notebooks with a real-life scenario. And for that, I'm going to switch over to my Azure environment first, because this is where you get started. When you have an Azure subscription and logged in, you should see the following view here. When you want to create a new machine learning workspace, you just click Create New, write in Machine Learning, click Create, and then we give it like define a resource group, which you can create here. Resource group is a good idea. For example, you can put in the one resource group a different components that should work together. And also, if you want to remove the whole resource group, then it's easier to just remove the resource group, and it will remove all the other resources inside it. It can be called like demo VS. I should call it something like this, because I'm sure I have some demo environments already. And then we also need to have a container registry. It's a good idea to create one, and it's enough to have a standard for this matter. But I'm not going to create one now, because I already have a machine learning workspace. So after this is deployed and it's ready to use, it is going to navigate you to this view. And if you click on Launch Studio, you should see the following page. All right. So what I'm going to start with is like introducing you to the notebooks. And I have already prepared some code for you, so we are going a bit faster. But like I don't know if you have ever worked with Jupyter notebooks before, but I think you can see that it's a quite similar environment. You have the folder structure that you work with. You have the navigation pane here, like the compute cluster also. You can choose from here that I'm going to need to run when I want to run some code in this notebook. It's a good practice to stop the compute when you don't use it because it can be quite costly. Yeah. The other cool stuff around this notebook that you can actually choose to work in Jupyter or in Visual Studio Code. It's pretty awesome how it looks actually. So if you want to see it, like ping me later and I can show you. But the coolest part from here that you can also, with the use of the terminal, you can also connect to Azure DevOps, for example, and you can put on your code into repositories and you can use the whole what's it called, source control capabilities as well. All right, so the data we are using for this part is about buildings that has been collapsed in the earthquake of Nepal. And this data is coming from the Central Bureau of Statistics. And it contains valuable information about numerous properties, like the area, age, and demographic statistics about numerous buildings. So what we want to do is to build a predictive model which is able to answer the question by learning from the data we provide, like which buildings are in danger when another earthquake comes. Okay. So as I said, for this part, we can use Python packages that are actually built in already to the environment. And you can see I basically just have to import it and just use whatever package I want to go with. So what I do here is that I create a data frame where you can see all the columns that I just show you now. This is like, for example, the number of floors, the age of the building, and so on. And these columns will be used as feature for training the predictive model. So when we have a set of observation, it is useful to summarize features of our data into a single statement called descriptive statistics. Because instead of like scrolling through this data and try to understand all what is written here, we can use some nice Python functions. And that is df values does describe. Right. In the first row, you can see how many not null values are in this column, in the specific column that we observe. Because Python's describe function only counts the not empty fields and also the numerical columns only. Another interesting observation, oh yes, and I show you in the beginning that we can see some statistical information like the mean, standard deviation, minimum, maximum, and all that. So an interesting observation with the has underscore columns like this one, for example, that the minimum is 0 and the maximum is 1. So I could assume that these are probably true or false values, but I cannot really be sure about it. But we can check this on, for example, this column. If we say if we use the unique function, then it returns the distinct values of the chosen column. So we now are sure that these columns hold true and false values. I actually close this so we have a bit more space to show around. All right, another observation we can make here is, for example, with the count of floors, that there is at least 1 floor, but maximum 9 floors in these buildings. Or with the age, that is minimum 0 years old, of course, but maximum 995 years old. Okay, so, right. We also can do some visualization to see more information, like in case of the age. Yes, for example, we can see here that the mean is the blue box, and that most of the buildings are between 0 and 200 years old, which is quite close to the mean. But there is a building, or maybe more than one, that is 995 years old. This is like an outlier value. So we would need to make sure that we take care of that as well. So I bring in another data set. And these columns will be, the ones I shown you, those will be used as features on the training data. And now I'm bringing in the labels as well. And then the labels will be on the end of this data set as the damage grade. The damage grade, I show you here, we have like 3 different values in the damage grade. The 1 is the low risk of damage, 2 is the medium risk of damage, and 3 is the high risk of damage. So our model is going to predict the risk by learning the experience data. And what we can also see here that how many features there are for each of the labels, so how many examples there are. The best case would be if these numbers were quite close to each other. So it is visible that the number 2 has much more examples than the label 1 and 3. This is a problem because if the model is trained on more examples with label 2, it more often returns the label 2 even when the risk is supposed to be high or low. Okay, we can additionally observe whether there is a relationship between the different columns. For example, here we see the relationship between the age and the damage grade. And for example, if the difference is positive, that means that the older the building, the higher is the risk of damage. And this is all nothing. You can even write your own machine learning models and data science tasks here in the notebooks. You can also clone your repositories into your folder structures here. And by using the terminal, you can commit and push your changes straight from Azure Machine Learning Workspace. But instead of building data wrangling actions and predictive machine learning models from scratch, let me show you the next tool in the Machine Learning Workspace that is called the Designer. So data scientists can use a rich set of built-in algorithms, feature engineering, and model evaluation to quickly build machine learning models or prototypes. So machine learning experts can visually craft their complex machine learning training pipelines with their own code. And machine learning engineers can construct the operations pipeline in the similar drag-and-drop approach. We can use built-in modules, data visualization, model evaluation, and we can automatically generate scoring files, register models, and build images using Kubernetes for scale, and I could go on. Let me quickly show you a bit of how the Designer works. So from the main page, we can go to Designer, and I have prepared you already a few things here. I'm using the data like I showed you in the previous demo. This is the joint data that we've worked together with. And here we have, I'll just quickly show you. So we have the same columns and we have the damage grade as well available from here. Yes. And for example, we can also visualize this. We have some statistics written here and some visualization that I told you about. It's the number 2 has a lot more examples than the 1 and 3. We need to take care of this. So what we do first is that with the use of the select columns in dataset, we exclude some noisy values like the non-numerical values or the ones that are doesn't feel like. So I did a lot of investigation on this data. So at this point, you can just trust me that I only included columns that are useful for this task. Then we do some normalization to exclude the outlier values, like we see in, for example, at the age column. So the goal of the normalization was also to change the values of numeric columns in the dataset to use a common scale without distorting differences or losing information. And this is really useful since most of the columns have different metrics with different scale. Now, all the columns will be on the same range of values. And as I mentioned before, the challenge of working with imbalanced data sets in most machine learning techniques is ignored and in turn have a really poor performance. Like imagine if you train your machine on only an example where the most of the time the damage grade is just medium. Then you get a set of data from your client saying that, okay, let's run your model on this one. And then it returns low or medium risk of damage for buildings that are actually should have high risk of damage. This is a big problem. And for this, you can apply SMOTE approach. And with the help of this technique, we can provide a model close to equal number of samples. And why cannot I? Yeah, so like sometimes I like that's how this thing is making fun of me sometimes. So I ran this yesterday and I could have shown you how the output looks like. I'm going to run this and maybe see if it works quickly. We will see. I always say that you should not run anything live in a demo, but whatever, we'll see how fast it is going. All right, but the idea is that after SMOTE, we can start, there we go. We can start by just looking at the result first. So after doing this SMOTE, you see we have almost the same amount of features for all the damage grades. So that's cool. We can go on with this. We could play longer with that to make it even closer, but we just want to go on right now. So we split the data for training and validation test, or validation or test data. And then we can choose a model to work with. And you don't need to fully understand really yet for what machine learning algorithm you should use, but at least we know that regression is going to give you an amount, for example, the car prices next year, and the classification, for example, would choose from a category, so we might want to choose from the classification algorithms. And you can also choose more than one from here, and you just have to connect it similarly like I did here. You just import more than one algorithms for it. All right, and then what I use here additionally is the tune model hyperparameters. And this is going to get the best fitting parameters that is used for this iteration to reach better prediction results. And then scoring, that it does the prediction basically. And then the results can show, first of all, the scored labels, like what is the damage grade given for the buildings, and the probabilities of the labels that should have been given. All right, and evaluation is also an essential step by building a machine learning model, because it tells us how our model works. And when you're happy with the evaluation result, I'm not happy, I'm saying it already. This is just 56% of accuracy. I could do better than that. But you know, the aim is here is to improve your model, and then if you want to have an even better performance, you can just continue playing around in here. You can even download code from here, from the designer. And you can also just deploy it from here. But if you don't want to do that, I can show you another way, another component called automated machine learning. So you can automatically build and deploy predictive models using the no-code UI or through a code-first notebooks experience, but you can increase productivity with easy data exploration and profiling, and with intelligent feature engineering. You can easily create accurate models, customized to your data and refined by a wide array of algorithms and their parameters, and you can build responsible AI solutions with model interpretability and fine-tune your models to improve accuracy. So the UI provides the dataset integration, so you can use different data sources. You can use the featureizer and can be very well customized, and you can use out-of-the-box model explainability. And as I mentioned before, the UI is quite understandable. I just go ahead and start up, not the designer, the automated machine learning. And you can just create a new run. And then I would use the same exact data and say next. And then we want to create a new experiment. Define the target column, which is obviously the damage grade. And then we choose a compute cluster. And in the next step, we need to choose what task should be done. We can go with classification, and we can enable deep learning for better results. And if we click finish, then the run starts up. All right. I won't start it up now because I have prepared a run before the session, because it takes a while to initialize and run through a lot of models. Because what this does is like running different models and comes back with a nice accuracy, like with the best parameters and with the best possible results. And for this algorithm, it returned the best accuracy because it is like always showing the best one in here. And we can take a look at the explanation as well, which is now in preview version, but at least providing us some useful information. For example, the important columns are defined. I just don't know why is it so slow. Come on. Yeah, but there will be like a few different things that you can see. There we go. So for example, we can see the model performance. You can see the important features from the data. You can show a lot of important features. This is showing the most important ones from your data that you give. Okay, so we can also download the code of this specific model, and you can add further improvements before deploying it. But you can also easily deploy it from here by clicking on this button. And if you want to learn more about your model, you could take a look at the metrics as well, where you can visualize all kinds of details. For example, my favorite is the confusion matrix. Yes, I like the confusion matrix because it is showing like how confused your model is. I mean, for example, if you look at this, then it's, in 1,000 cases, it was predicting 1 when it was actually 1 as a damage rate. And in 12,000 cases, it's correctly predicted number 2, and 5,000 cases, it correctly predicted 3. And like 28 cases, it predicted high risk of damage when it actually was low risk of damage. So this is how confused my model is. All right, let me step back for a moment to the experiment page. Where you can see the summary of the run. And if you click on data guardrails, you can find some improvement ideas proposed by the tool. This also states what I mentioned before, that we provided unbalanced data. And this is, we can say thank you for the automatic featureization. All right, so with that, I want to go and show you where can you find more and where can you continue this learning of machine learning workspace. And on the first link, you can learn some techniques like planning and creating a suitable working environment for data science workloads on Azure. You can run, you run data science workloads on Azure. You can run the different experiments and train predictive models. And in addition, you manage, optimize, and deploy machine learning models into production. And then the second one, you find all the Azure machine learning related concepts that you would apply while working on data science and machine learning pipelines. You can also find all the steps I showed you today, like creating a new workspace, how to use the notebooks, the designer, and the automated machine learning. And that additionally to that, you will find a very well-detailed documentation for some other cool tools like responsible machine learning, and more about MLOps, deep learning, and a lot more. And before saying goodbye, I want to show you something else, because I understand that sometimes it doesn't make sense, like, okay, cool, we make all these information. But for example, with the designer, I added a bit of an extra here, because what if your customer actually would like to see some results? So we get data from the customer and give it to the model that we trained. And then we score that model, prepare the data, and we can put it into a CSV file, for example, and that could be also handed over to the customer. And you can see the results inside here, inside the workspace, actually, if you go to data stores. And if we go to data stores, I just put this in and try to find it. All right, and then we have the data.csv as a result. And I want to see, I think in the editor, I can see that, yeah, there we go. And we have the building ID that we got from the customer. then this identifier has a low risk of damage, but this building will have a high risk of damage, and so on and so on. And using this information, our customer is maybe able to see whether that building needs some strengthening before another earthquake or not. And by this, maybe save a lot more lives. And with that, I'd like to say thank you for your attention, and I hope you find this session beneficial when you build your next AI solutions. It was a great honor to be one of the speakers at that show. So thank you a lot again.
Thank you very much, Eva.
Hi, Sherry.
Hi.
Hello.
Hi.
Is that Rasmus with deepfake or is it Sherry?
No, this is also with the deep fake. So
Yeah, great talk, really awesome. I don't know, is some question coming at the moment in the comments? At the start there was some discussion, will there be singing in the end or there will not be?
Honestly, I was not prepared that I should sing as well today. So
maybe you can tell us what is your favorite song to sing when you go to karaoke?
It's not really a favorite, but this is what I start with. Is it really like no? So, but like this is this song I usually start with because it is like training my voice quickly. And that song is which one should I state first? Well, I think mostly the song from the, you know, the song from the, what is it called? The Prince of Egypt.
Prince of Egypt, no.
The Mariah Carey and Whitney Houston song. I won't start singing it now. No.
Okay.
What is yours, Goran?
Tequila. You just have to say 3 times tequila or 4 times in 3 minutes.
I think I heard that one before in a karaoke party.
Mine is I Want to Break Free.
Oh yeah, that's cool. That's cool.
Yes, great. So will you send us the link to your slides, because we are going to send like a follow-up email to everyone with more resources, and maybe I will add some more information about that, what are the maybe learning modules that people can actually use to learn more about this topic.
Yes, I think it's a good idea to look into the training as well and to the concept of the workspace, because it is a lot of information that is written there, but it is valuable and it is almost enough to get started, really. So, for example, with the working, oh yes, I could actually show that because that's funny, because we have time anyway, as long as we don't have questions. For example, I can edit this in VS Code. And if I do that, I have a lot of things open here. Ignore that. I'm not sure if it will be able to open it now, because I am connected maybe with another Azure account, and that's always a problem when I'm using like 3 different accounts at the same time.
I can imagine.
Yeah.
By the way, I just realized that I'm here at this show with 2 times Microsoft AI MVP.
Nice. Yes, you are actually right. All right. So let me open up one of my favorites instead. Like, can you like stop for a second? You don't have to do that. All right, guys. Let me just start this over. So. All right, and now it still tries to connect to something, which I don't understand why does it do that. But what I want to do is just I show you quickly what capabilities this has, Because basically what you can do with this Visual Studio Code together with Machine Learning Workspace is that whatever changes you do here, you can just connect it back straight to ML Workspace. And you know that Visual Studio Code can be connected to DevOps as well. So you can either put up your code to source control from here or from ML Workspace as well. And I don't see why it doesn't want to do anything. And this is like a live demo situation, right? That nothing wants to work.
That is completely normal.
That is normal.
Demo God, please.
Yeah, but I had a screenshot about it somewhere, so at least. Okay.
Yeah, I really like that VS Code these days. You can just leave in VS Code. And
yes, you can actually. And you can just do everything here.
Yes, that's amazing.
And these are also like Jupyter notebooks, as you can see. You can similarly add a code or a markdown or whatever. You can see the same console tools that like we have in Visual Studio Code as well. And what else you can see that is really awesome, I think. That's not what I wanted. No, but when this is done, I can show you this data frame information as well somehow. So when the data frame is available, it's like always like a wondering, like, how was it? Ooh, that was so cool. How did I do that? And then, it's the cool stuff about these things is that you actually are able to show around things really well. And if I could figure out how to do that, it's so annoying because like sometimes it works and sometimes it's not, just the normal stuff. Because there should be a panel up there saying that, okay, let's show all the available variables, which it doesn't want to show right now. No, but whatever. I will show you that next time. That's not a big deal, really.
Great.
I need to bring it up at some point because that was working yesterday, right?
Then it means that we should have you back again. At
yeah,
some point.
and I can play around with DevOps.
Yes, that would be good. That would be a very good topic. So let me quickly share my screen here. I don't know if I already mentioned in the beginning, so you can all get the Azure Heroes Learner Badge by quickly scan this QR code. And our speaker, Eva, she's going to get another type of Azure Heroes Badge, which is a kudos badge for thank you for speaking at Dev Show today. So for those of you that you are not familiar with the Azure Heroes program, I always call it as a token of appreciation from Microsoft to the community for learning and building on top of our technology, or for going some step further, like for example, Eva and Goran, and contributing back to the community. You can always go and learn more about the program on our website, and also nominate your friends or yourself for some of the other badges that we have out there. And by checking our hashtag, you can see that what the community is saying about Azure Heroes. And of course, you can always share your badges on the social media with this hashtag as well. Feedback. Okay, Goran, you want to say feedback?
Yeah, we would like to hear your feedback, so please scan this QR code and let us know what you think about this show, what you would like to hear in the future, which speakers or which topics you would like to see. So yeah, go ahead, let us know.
And one tips is that if you're filling out our feedback form, one of you magically will be chosen to get a special swag box. And also there's a field there for Eva as well, that if you want to give her feedback, we will definitely make sure that we are bringing that feedback to Eva as well. And our upcoming events. If you missed Build, Azure User Group Copenhagen has this session on June 3rd, this Thursday, that they are going to have like a recap of build, and it's going to, I'm pretty sure it's going to be a very fun event as well, with some swag boxes and so on as well, just saying. So join that on Thursday. You can find her definitely on the Azure User Group Denmark on Meetup. And as for us, on June 8th, we have Arari. Is going to talk about Java on Azure, and it's going to be actually 2 sessions, one on June 8th, and then the other one 2 weeks after that. I don't remember the date. and then the first one is going to be more of a theory, and then the second one is going to be a hands-on one. So tell your friend to join this session if they want to know more about the Java stack on Azure, because there are a lot of new announcements recently been about this topic. So Rory is going to talk about all the latest and greatest. You want to go for this, Goran?
Yeah, sure. We have interesting maker show coming up. And it's about 3D printed bionic hand and little IoT and Xamarin mobile app. So great story how one young man was helped out with this project. Really, really amazing. And yeah, show will take place on June 10th. So feel free to join us.
Yes, and Goran is going to be there again. So and then for those of you that kind of don't know about the Maker Show, it is normally kind of that the topic around IoT and AI is more about the innovation and inspiring projects. And this one is a very good example that how technology actually can, just like today's topic, it can have impact on people's life. That for this example, it was a hand that was built for a person to change that person's life. So with that, should we say goodbye?
Yeah.
So goodbye, everyone, and thanks for
Thank you
being
for today.
Thanks.
Thank
for
you. Bye.
Bye-bye.